Hey, today I'm going to uh, let you know the exact calculation of heart rate from the ECG strip. Now, as we just to give you a quick introduction, it's QRS complex, P wave, T wave, and to let you know about the big squares, it's a big square one. Means it's known as one big square, which measures 5 mm and it contains 25 small squares within. Now, as we know, the speed of ECG paper, that is how it runs in the ECG machine pointing, it's 25 mm per second. 25 mm per second, it means 5 big squares are running in forward direction and the pan in backward direction in 1 second. Now, just to uh, give you a quick explanation, we will start by taking this ECG strip example. Now, let us say we have to calculate the heart rate. Now, what we will do first? It's we will take the QRS spike at which is superimposing on the big square, that is taking this, and next QRS spike, that is it's this. Now we can see the 1 2 3, approximately 3 big squares we are taking. Now the 3 big squares means it's 15 mm, because 3 into 5 big squares, as 5 big squares is 5 mm, so we have 15 mm. Now the explanation which I am giving is the basic explanation how we calculate the ECG, as we also know that some shortcut tips also to know it. Just divide by 300, 300 divided by 300 upon the number of big squares, but many of us want to know the real explanation, how it derived. It is actually the derivation, how it's the heart rate is derived from the ECG paper. We are taking 15 mm. Also, with this method, you can even take this 1 mm slot also, that is 16 mm. But in normal reading, we can't take 16 mm, so it won't be so accurate. But in this method, you can take even to any precision. For example, I am taking now for sake only 15 mm. Now we know now I am going to apply only a simple elementary math. Now when we know that 25 mm per second is ECG paper's speed. So as we know, what is one beat? Now a beat is defined by a slot in which one cardiac cycle is completed. Now here we can see that one cardiac cycle is taking 15 mm. Now as we know the speed, so by speed 25 mm per second, it's the speed of ECG paper, and we also know the 15 mm is the slot of one cardiac cycle. So with this we can derive the time. How? Let us say, now when 25 mm is going in 1 second, so 1 mm with paper will be drawn in 1 by 25 seconds. It's simple as that. Now we know our the QRX complex consecutive difference is 15 mm here. So 15 mm, how much one beat time is taken by 15 mm? Now we will multiply by it to 15 mm. We get, just to simplify, we get 3 upon 5 seconds. Now friends, it's very easy now. We have now derived the time of cardiac cycle, that 3 upon 5 second is the time duration of the patient's cardiac cycle, that is 3 upon 5 second is taken by heart to beat in 1 second. So now now we know the formula of, we know the heart rate. What is heart rate? Heart rate is beats, number of beats per minute or per 60 seconds. Now we know uh, one beat is taking 3/5 seconds. Now in 1 second, that is in 1 second, how much beat will be executing? Now it's simple unitary method, that 1 second 5/3 beats. Now in 60 seconds we can easily derive now. Obviously 60 seconds into 1 second equals to, multiply both by 60 here, that is 60 seconds is 1 minute. So in 1 minute we'll know the beat. 5/3 into 60. Here we go. We have 100 beats per minute. A better perspective to derive the heart rate exactly. Now we can also put here 19 mm or 20 mm and we get the exact beats per minute. I hope you are smarter than before now by watching this video.